Hi, I'm Hannah Muller, and this is my presentation on cognitive neural prosthetics, or CNP. So, prosthetics are limbs for amputees or people born without limbs, and amputations can be for a number of reasons, but most commonly it is trauma or disease. And prosthetic innovations have allowed patients to have increased mobility, a better control of their limbs, and prosthetics can also be made for athletics to allow amputees to participate in different kinds of sports. So, neural prosthetics are a new technology that's being developed, and it involves an implant in the brain that can uh, receive signals and impulses and send those signals to a device like a prosthetic and allow amputees or paralysis patients to move. So, neural prosthetics record the cognitive state rather than the motor or sensational signals because it wants to recognize the signals that interpret the motion and understand the mechanics rather than the actual execution of it. And it uses cortical signs of intention, motor imagery, decision making, forward estimation, executive function, attention learning, and multi effector movement planning. So basically, imagined movements can be turned into real movements based on the impulses and signals received by the implant. So they work because they record the activity of population of nerve cells. They can transmit the signals wirelessly to an external assisted device like a prosthetic, and they use functional magnetic resonance imaging, or fMRI, to experiment and identify pattern recognition receptors, or PRR. And this technology has been used throughout the development of this new technology. And electrical stimulation of posterior parietal cortex in human patients invoke the conscious intention to move various body parts, even though no movements result from the stimulation. So this goes back to the imagined movement can become a real movement. So even though a patient cannot physically move this extremity or body part, they can create the concept in their head of the movement, and based on those impulses, the implant will allow them to act on that. And it uses primary motor cortex cells, and they can be trained to respond without invoking the movement, but it's just that the movement can be imagined. So they're implanted in multiple parts of the brain, or they're being studied right now to see which is the best area to implant these. And currently, it's believed that the sensory motor cortex and the parietal reach region and the motor cortex are the best locations. And they're inserted slowly and they want to minimize compression of the cortex. And the insertion is usually at about a depth of 2 millimeters, or that's shown to be the most successful. And wires along the connector are cemented to the exposed skull and the exposed cortex, and it is covered with a foam and then sealed. So these prosthetics can also be used by paralysis patients. And some background on paralysis is that it is estimated that nearly 5.6 million people are paralyzed in the US. And paralysis can occur due to things like trauma or illness. And if patients have the mental capacity to where they can still plan movements and they just can't execute them, then um, they can become they can apply to be a participant in like different studies, and uh, they can qualify for this new type of technology. So patients can use the implants to move prosthetic limbs, or they're also using these implants to with eye recognition technologies to control cursors and other electronic devices. So the future and the ultimate goal of this technology, they expect the value like to among the high level cognitive signals, and then it can be used and will potentially enhance the ability of paralyzed patients and amputees. And they want to improve the liquidity of movements for amputees and allow greater mobility. So, because currently the movements are somewhat rough or jagged, but the technology has been increasingly improving. And they also want to improve the technology with lower limb prosthetics because right now the technology hasn't been successful with that. It's been more successful with upper extremities, such as like the arm or hands. And they want to improve lower limb extremities because they're struggling with balance and patients falling over. And so those are some of the goals for the future of this technology. So here's a video to show how the hand can move, and it shows that it's pretty fluid
robotic limb
at the
that
moment, and the
has many
ability and like
degrees of
the different
freedom is very
strengths
similar
of
to an
the
actual
hand and how
human
easy it
limb.
is to control.
So you can see it's very dexterous. It has many, uh, essentially all the degrees of freedom that you would need to do things that humans can do. It can operate on very soft objects. It can use, not crush water bottles and really delicate
Okay,
objects.
and
And it can
then
also
so this kind of just shows like the innovation with this new technology, and that it can be used for prosthetic, or for this prosthetic can be used for paralysis patients and for amputees. And
uh,
then here is my works cited. Thank you for watching.